Critical angle and total internal reflection. In our earlier session, we have learnt about laws of refraction. We had learnt earlier that refraction is the bending of light rays at the surface of separation from one medium to another medium of different densities. The light ray passes from rarer medium to denser medium. When it passes from rarer medium to denser medium, it bends towards the normal line, and when it passes from denser medium to rarer medium, it bends away from the normal. The angle between the incident ray and normal is called as angle of incidence. The angle between refracted ray and normal is called as angle of refraction. When the light ray travels from higher density to lower density in different angles, the refracted ray bends from the normal, and the angle of refraction is greater than the angle of incidence. When angle of incidence increases, angle of refraction also increases. At a point, the refracted ray takes the path along the water surface, and the angle of refraction is less than 90 degrees. When the light ray passes from denser medium to rarer medium, the angle of refraction is 90 degrees. The corresponding angle of incidence in the denser medium is called as critical angle. Total internal reflection. When the light ray traveling from denser medium, if the angle of incidence is greater than the critical angle, then the light ray doesn't enter into the rarer medium and reflects back into denser medium. This phenomenon is called as total internal reflection. During the phenomenon of total internal reflection, the light ray doesn't get absorbed or transmitted or refracted from the surface of separation of water. The light ray always gets reflected back into the denser medium.
Mirage. Mirage is a natural phenomenon of formation of inverted images of distant objects by total internal reflection. Heat from the sun heats the land and air. The layer of air closer to sand is hottest and least dense. Upper layers are relatively colder and more dense. The ray starting from the tree travels from denser to rarer medium and suffers refraction. When the angle of incidence exceeds critical angle, total internal reflection takes place. These rays appear to come from the image of the tree.
Optical fiber. In this module, you will learn about an optical fiber. A long straight hallway can easily be illuminated by simply pointing a torchlight down it. But what will you do if the hallway has multiple bends? Well, you can fix plane mirrors at the bends systematically so that light is transmitted through them by repeated reflection. This forms the basis for the working of an optical fiber. An optical fiber is a glass fiber that is transparent, flexible, and is as thin as human hair. An optical fiber uses light in the infrared region which has wavelengths longer than visible light, to transmit digital information. It transmits light and digital information over long distances by total internal reflection. Before learning how an optical fiber works, let us recall the concept of total internal reflection. Look at these two optical media with different optical densities in contact with each other. The critical angle for the pair of media is inverse sine of the ratio of refractive index of the rarer medium to that part of the denser medium. Let us now return to an optical fiber. An optical fiber has three main parts: a core, a cladding, and a coating. The core is made of doped silica, the cladding of natural silica, and the coating of plastics. The core is optically denser than the cladding. A light ray, say OA, strikes one end of the optical fiber at a smaller angle of incidence. The light ray refracts and enters the core. The refracted ray, say AB, strikes the core cladding interface at an angle greater than the core cladding critical angle. Therefore, AB undergoes total internal reflection and is reflected back into the core as BC. So, in an optical fiber, transmission of light occurs through the core only. The main purpose of the cladding is to reflect light to the core. The core and the cladding are very delicate. They are protected by the coating from physical damage and moisture. Optical fibers are widely used in the medical field to diagnose many ailments. For example, in upper gastrointestinal endoscopy, an endoscope is inserted through the esophagus into the stomach of the patient. An endoscope uses optical fibers to transmit light. In this module you have learnt, an optical fiber is a glass fiber used to transmit light and digital information over long distances. It has three main parts: a core, a cladding, and a coating. It transmits light and digital information by repeated total internal reflection. It is used in telecommunication and medical field.